One of the tasks on the test for Chapter 3 that students have to do is find the greatest common divisor, or GCD. And a divisor is a number that these can be divided into groups of. So, for example, 2 is a common divisor of all of these because all of these numbers can evenly be divided into a group of 2. 30 by 15, 24 by 12, 6 by 3, and 9 by 8. But we want to find the largest number that they can be divided into groups of. And one method is to write out all the factor trees of each number. So 18, you can do a full factor tree. And then write it as a string of prime numbers multiplied together, or a string of prime factorizations. 3 times 3 times 2. So 18 is you could write it in any order. I'm going to write it with the 2 first. 2 times 3 times 3. 2 times 3 is 6. 6 times 3 is 18. And these are all prime numbers. And 6, that's one a little simpler. We have 2 times 3. 24. We have 2 times 2 times 2 times 3. Obviously, you can do these in your head, but it might be a good idea to do the factor tree if necessary. And 30. Let's see if I can do this in my head. Well, I know that 2 times 15 is 30, and 3 times 5 is 15. So I could say 2 times, instead of 15, 3 times 5. So now to find the GCD, or the greatest common divisor, I need to find common factors that are in each of the numbers I'm looking for. Well, I see they all have a 2, so this takes care of this 2. And they also all have a 3. This one has a 3, 3, 3, 3. They each have to have that 3. So I take away these 3's. And now 5 doesn't have any corresponding 5's in any of these others. And neither this 3 doesn't. They'd have to be a 3 in every other number. So 2 times 3 is 6. And so according to this method, 6 is my greatest common divisor. But I don't need to rely on the method. I can check it. So 18 divided by 6 is 3. 6 can be divided into groups of 6, one group of 6. 24 can be divided into groups of 6. 30 can be divided into 5 groups of 6. So there's one problem. Let's do another that you might see on your test. We're looking for the GCD between 30, 15, and 12. What number can 30, 15, and 12, what group can a number of, what can they each be divided by evenly? What's the greatest number they can be divided evenly into? So I can write a prime factorization of 30, and I get 3 times 5 times 2. I did that one before. I did it the opposite way. I did 2 times 3 times 5. 3 times 5 is 15, times 2 is 30. These are all prime numbers being multiplied together. My prime factorization string. And then 15, I get 3 times 5. And 12, I get 2 times 2 times 3. So I'm looking for pairs, and here's a 2. And I got a 2 down here, but I don't have a 2 as a prime factorization string for 15, so I can't use that. How about a 5? I have a 5, oh, no 5 here. And then I have a 3. The 15 has a factor of a 3, and 12 has a factor of a 3. So I can use the 3. But it doesn't appear I can use any others. This 2 I can't use. I can't pair these 2 together. They have to be from different numbers. And if I'm not multiplying by anything, this is going to be my greatest common divisor. The greatest common divisor between 30, 15, and 12 is 3. Now what I should do is check it. I can grab a calculator. 30 times 10 is 3, so 3 is a factor of 30. 30 times 5 is 15, and 30 times 4 is 12. And is there a larger one? Well, how about 6? Well, 6 can go into 30, but not 15. It does go into 12, and I can experiment a little bit with this, but it works. This method does work, this little factor tree method. And my GCD is, greatest common divisor, is 3 for this one.